Hello, Calc 3 class. For section 11.5, there were some students who emailed me about problem 10. It's a little tricky, especially part B, so I thought I'd make a quick video to show you how it's done. Okay, so I'm going to read the question here. So consider the planes, these two equations. There's two planes. You need to find the angle between the two planes. Now that's easy to do. Just get the normal vectors and then find cosine of theta and get the angle. There's a second part that's more complicated. You need to find the parametric equations of the line of intersection of the planes. Okay, so I'm going to draw rough graphs and work through the questions here with you on my document camera. So pause the video here. Alright, so copy down the two plane equations. Now remember, your version is going to be slightly different from mine. So as I said earlier, you can call n1 to be the first normal vector, and that's negative 4, 1, 1, and 2 is 8, negative 2, 4, and then cosine of theta is going to be the absolute value, because we need the acute angle between the two, n1 dot n2 divided by the magnitude of n1 times the magnitude of n2. Let me just do that real quick. So we have no brackets, we've done the dot product. Magnitude here would be 16 plus 1 plus 1, 64 plus 4 plus 16. I think that's absolute value of negative 30, so it's 30. And then on the bottom, the square root of 18 times the square root of 84. Alright, we can use our TI calculators. And I think it wants it in degree mode. I'm in radian mode, better change that. And then cosine inverse, I said, 30 divided by, now make sure you put both the terms in the square root, and then we get 30, it's about 39.5097. I don't remember the rounding directions, so I'll go check it later. This is the part that I was getting emails about. So basically you have two planes. Let's pretend this is one plane here, and then you have another plane going like so. Kind of like if you have the binding of a book and there's two pages. You found the angle. Now you need to find the equation of the line of intersection. So back in algebra, when you needed to find intersections of a system of equations, you just solved by elimination or substitution. And typically you had two equations and two unknowns. But over here we have two equations and three unknowns. So we're going to try to solve it anyway. But what you notice here is that you'll have an infinite number of solutions. You see, because the two planes intersect along this line and it goes on forever. And that infinite number of solutions is where the parametric form comes in. So you'll use the letter T as a parameter. Okay, so back in algebra, you learned little techniques like in the first equation, you can multiply this by 2. Okay, so I'm going to cross that out and write that here. Multiply everything by 2. Negative 8x plus 2y plus 2z equals 8. I'm going to copy the second equation below and then add the two equations. This is called the Illumination Method, where you eliminate a variable. It turns out that we actually eliminate two variables, so you get 6z equals 24, or z is just 4. Okay, so apparently this line of intersection has just 4 as for z value. Okay, I'm going to go up here to the top equation and plug in 4 for z. So I get negative 4x plus y plus 4 equals 4. I just replaced this z with 4. Okay, now the 4's cancel out, so I can solve for y. Y is 4x. So this line of intersection is given by y equals 4x, where z is 4. So the parametric form, we want to use the parameter t, so I'm going to call x to be t. So I can replace this x with t, and y would be 4x, which is 4 times t, because x is t, and z is just the constant. Okay, so this would be the parametric form. Now you could have let y be t. If y is t, then x would be t divided by 4, and then z would still be 4. Z is a constant. So there's equivalent parametric equations for that line of intersection. You could have even let x be 5t, then y would be 20t, and so on. Okay, so I'm going to switch back to WebAssign so you can see how I'm going to type in the answers. The angle is rounded to 2 decimal places. That'll be 39.51 then. And for this one, it's a use t and separate your answers with commas. So I'm going to go x equals t, comma, y equals 4t, comma, z equals 4. Let's check and see if that works. All right. If I change this to the second set of equations, it should still work. Okay, hope that helps. Keep up the good work.